Now we see the problems on sine and cosine transforms. The first problem, find Fourier cosine transform of f of x defined by f of x is equal to cos x for 0 less than x less than a. Okay, must see the question. In last problems we have find Fourier transform ante మధ్యలో ఇంకా ఏం వర్డ్ లేదు. Fourier transform అంటే e power isx ఉంటుంది ఇంటిగ్రేషన్ లో. But here find Fourier cosine transform of f of x. What is the definition? For 0 less than a, 0 less than x less than a, function is f of x, otherwise it is 0, function is 0. Okay, the Fourier cosine transform, its definition, this one, symbol is f of x, means Fourier cosine transform of f of x. So the Fourier cosine transform of f of x is equal to, definition amma, integral 0 to infinity f of x cos sx dx, but the interval is 0 to infinity. Here the given function defined only in 0 to a cos x, otherwise after a it is 0. So a దగ్గర break చేద్దాం interval, that is equal to integral 0 to a, only 0 to a లో మాత్రమే valid అమ్మా. So let integral 0 to a f of x, integral 0 to a లో f of x is cos x cos sx dx. Now it can be written as multiply with 2 and divide with 2. So 1 by 2 into integration local 2 రాద్దాం, 2 cos x cos sx dx. This term in the integral is in the form of dx తీసేయండి అమ్మా, ఇంటిగ్రేషన్ ఉంది కాబట్టి dx. What is the remaining? 2 cos x cos sx. You see 2 cos a cos b is cos a plus b plus cos a minus b. Now we have in the place of a x, in the place of b sx. Now use this formula, it can be written as 1 by 2 common, integral common, this place, in this place of 2 cos x cos sx you write cos a plus b cos x plus sx into plus, now here 1 by 2, that is equal to 1 by 2 integral 0 to a cos, here you get x as common, 1 plus s into x dx అంటే cos ax లాగే ఉందమ్మా, plus 0 to a second integral 1 by 2 common for both this, second integral 0 to a cos x common తీస్తే 1 minus s dx. What is integral cos ax dx? a అనుకోండి 1 plus s ని, integral cos ax dx is sin ax by a రావాలి. That means 1 by 2 sin this one by x into ఎంత కాన్స్టెంట్ ఉందో అంత 1 plus x 1 plus s plus this also sin 1 minus sx by 1 minus s. Apply limits 0 to a. First you apply a. What we get? 1 by 2 sin 1 plus s into a, x place లో a ma, by 1 plus s plus sin 1 minus s into a by 1 minus s. Upper limit. For lower limit 0, sin 1 plus s into 0 means sin 0 is 0. Here also x 0, 0 into anything is sin 0 means 0. కాబట్టి 0 for 0 sin function ఉన్నప్పుడు 0కి 0 అయిపోతుంది, ఇంకా చూడాల్సిన అవసరం లేదు. Now the Fourier cosine transform of given function f of x is equal to this value. Okay, see the next problem. Find the Fourier cosine transform of f of x defined by f of x is equal to x. ఇందాకైతే కొసైన్ ట్రాన్స్ఫార్మే అడిగారు, ఇక్కడ కూడా కొసైన్ ట్రాన్స్ఫార్మే, కాకపోతే ఫంక్షన్ ఇందాక కాస్ ఎక్స్ అని డిఫైన్ చేశారు 0aలో, ఇక్కడ ఎఫ్ ఆఫ్ ఎక్స్ ఈజ్ ఈక్వల్ టు ఎక్స్ అని డిఫైన్ చేశారు. ఓకే, అదర్వైజ్ ఇట్ ఈస్ 2 minus x. ఫర్ 0 1 ఎఫ్ ఆఫ్ ఎక్స్ ఈజ్ 1, ఫర్ 1 to 2 it is 2 minus x function, ఫర్ గ్రేటర్ దాన్ 2 ఫంక్షన్ ఈజ్ 0. ఓకే, 3 ఇంటర్వెల్స్గా డివైడ్ చేశారమ్మా. ఇంటిగ్రల్ 0 to ఇన్ఫినిటీని 0 to 1 చేయాలి, ప్లస్ 1 to 2 చేయాలి, ప్లస్ 2 to ఇన్ఫినిటీ చేయాలి ఇక్కడ. నౌ బై ద డెఫినేషన్ Fourier cosine transform of f of x is equal to ఇంటిగ్రల్ 0 to ఇన్ఫినిటీ f of x cos sx dx. దీన్ని వచ్చేసి ఇంటిగ్రల్గా డివైడ్ చేస్తున్నాము. Then it can be written as integral 0 to 1 f of x cos sx dx plus 1 to 2 f of x cos sx dx plus 2 to infinity f of x cos sx dx. But in the first interval for x 0 less than x less than 1, the function is x ma, x పెట్టాం. Next in 1 to interval f of x is 2 minus x. Greater than 2 ki f of x is 0. Finally we get two integrals. Next this is in the form of integral u dv. This is integral u dv. Okay, you write here integral u dv can be written as u into v minus v into integral dv cheste ee value vastundamma. Apply 0 to 1. Here also you observe 2 minus x is u dv. Apply integral u dv form, you get this one. Here also you apply limits. For first one limits 0 to 1. For second one apply limits 1 to 2. For this one 1 to 2 apply. Okay, apply 0 to 1 for the first integral values and apply 1 to 2 for the second integral terms. See this one, first apply 1, what you get? First upper limit 1, lower limit 0. See this one, first x is equal to 1 substitution, 1 into sin s into 1 by s, ante sin s by s, minus into minus plus 1 into తీసేయండి plus cos s into 1 ante cos s by s square. Next 0, lower limits కి minus పెట్టాలి, minus x means 0 into anything 0. Next minus cos 0 1 కాబట్టి 1 by s square. This is about the first integral. See that this one, for these terms, for second integral, this one, these are the values. Substitute 1 to 0, 1 to 2. First substitute 2, 2 minus 2, 0. So first term 0 into anything. Next term minus into minus into minus, 3 minus lo naima minus 1 తీసేయండి, cos s into 2, cos 2s by s square. Okay, for apply of 2. Next minus అని చెప్పి 1 substitute చేద్దాం, minus 2 minus 1 sin s into 1 అంటే sin s by 1 into sin s by s కాబట్టి 1 into కాబట్టి 1 రాయలేదు. నెక్స్ట్ minus of minus cos s into 1 అంటే cos s by s square. Now you observe here, sin s by s positive, minus sin s by s negative values. Next, what are the remaining values? Cos s by s square. Cos s by s square means 2 cos s by s square. Okay, 2 cos s by s square. Next here cos 2s by s square with minus 1 by s square. What is the positive? 2 cos s by s square, 2 cos s by s square, 2 cos s by s square. అన్నిటికీ s square ఉన్నాయి టర్మ్స్ చూడండి అమ్మా, అన్నిటికీ s square ఉన్నాయి. by s square కామన్ తీసేస్తే cos s plus cos s, 2 cos s minus 1 by s square ఆల్రెడీ రాసాం, minus 1 minus cos 2s. Okay, we get these terms. Now 2 cos s minus 2 cos square s minus 1 by s square, 1 by s square, 2 cos s minus 2 cos square s. Now write 2 cos s as it is, denominator is s square, 2 cos s minus 1 as it is. In place of cos 2s you put 2 cos square s minus 1, 2 cos square s minus 1. Now you see here 2 cos s minus 2 cos square s plus 1 minus 1 cancel అయిపోతాయమ్మా. Finally we get 1 by s square, 2 cos s minus 2 cos square s. Now this is 2 కూడా కామన్ తీయచ్చు, 2 by s square cos s, రెండిట్లో cos s కామన్ ఉంది, సో 2 కామన్, 2 cos s, దీంట్లో కూడా 2 cos s into cos s అని అర్థం. Okay, now 2 common, 2 by s square, cos s also common. Now we have 1 minus cos s, which is the required Fourier cosine transform of given function.